So many teams still treat testing as a final step before every release. So the consequences are familiar. Late defect discovery, release bottlenecks, growing technical debt, and engineers spend more time fixing problems than creating value. Our next speaker believes quality should not be a checkpoint. It should be an engineering discipline embedded throughout the software lifecycle. Vishnu Mani is a software engineering manager at HealthEdge with more than 15 years of experience scaling global QA organizations and pioneering AI-driven quality engineering. He has built testing centers of excellence, championed automation first cultures, and helped organizations to transform quality into a shared responsibility. Today, he will discuss how teams can shift quality left, scale it right, and leverage AI to create faster, more reliable delivery pipelines. Now, please welcome Vishnu Mani. Hi, Vishnu
Hey,
Mani. Good afternoon.
hello, good afternoon, good morning. Uh, okay, we'll get started. Thank you for having me here. Thank you for the conference team 2026 for giving me an opportunity to speak about the real-time problems that we are facing in most of the organization, and I'm gonna cover up them in this 45 minutes of session. So basically, I started as data engineer and then transitioned into the managerial role, and then I'm currently leading a global enterprise organization where we have scaled more on the shift left strategy, and we have accelerated our automation by using the shift left practices and embedding with the AI. So in one sentence that I can cover, what are we going to speak on this topic? So it's basically quality doesn't break because of a bad code. It actually breaks because of organization growing faster than the QE art does, basically, right? Because we are in a very fast-paced environment where we need to ship code faster, right? So a bad code can potentially break the quality, but beyond it, because of the dynamic growth of the organization, which makes lot more it gets a lot more impacts in overall qualities. Uh, so what we will cover here in this agenda. Okay.
Can you just share your screen?
Oh, okay. I didn't. The screen visible?
Not yet. Okay.
Okay.
Yeah, now it's getting loaded. Okay, all good.
Okay. So what are we going to cover today? So we are going to cover the basic problem, the scaling problem, why the quality breaks at the organization level, not at the code level. And then the shift left practices, moving quality upstream with the mindset and the pipeline gauge and the advanced patterns. And then scaling the right, which is using the automation and AI as the force multipliers, where we will see more on the flaky test matrices and cultures. And then the case studies. I have brought in a couple of case studies from my past and current experiences. And then finally, we'll be closing with the takeaways and the next, which is the AI-driven QB goes from current to the next levels. Okay. So quality actually doesn't break at the code level, right? It actually breaks the art. So why? So code is just piece of a quality, but overall there comes a lot more of the culture, practice, process, and a lot of things goes into it. Right? Think about you have a value stream or a team that has a scrum team basically. So basically, I'm just going with my current experience, right? So we have values teams, and then there are a lot of scrum teams that are associated to the values teams, right? We actually ship code to the production on the own cadence that we have. So while shipping the code, what happens we ship a lot of new features, we ship defects, and we ship lot more of those things, right? So what happens basically, right? how can we reduce these escape defects by keeping the headcount wherever we are? So initially we had a X% of ratios in the QE, and then we actually increased the developer count, and we still had a X% of the QE count. But what we did something different here was like we were able to shift left all the way to the requirements level, and we were able to embed the quality practices in each and every stage of the SDLC, so that we were able, the quality became everyone's responsibility. It was not just only the QE's responsibility. So as we all know, the quality, when you speak about quality, it's only the quality engineering, right? Most of the organization actually think about in a way, the quality means the quality engineering. If something goes wrong or if something breaks, if production, gives you a critical defects, oh, what happened? Okay. What did we miss? Is it because of the quality? Don't we have coverage? Don't we have enough test case to cover up them? Yes. We have to stop that. We have to bring more of a culture shift in terms of the mindset rather than being addressing at the code level. Okay. The code has broken, but how should we stop this, or how should we stop bleeding such things in the future? How can we do the shift left and embed the testing in every phases? Okay. During my requirements, am I having everything? Where are the quality checkpoints? Okay, that goes with the product team. During the development, okay, what are my quality checkpoints? That goes with the development team. Do I have enough UT coverage? Do I have enough IT coverage? Is my baseline numbers of the UTs and ITs are getting passed? And then it comes to the quality. Okay, what I can add on top of it? Okay, now the requirements have got few defects. And then the UTs and ITs could able to cover up more of the coverages, add up more coverages. So from the quality side, how can I, bring more efficiency to the coverage part, and how can I bridge all of them in a pipeline of execution, the test executions, which can potentially minimize these defects. So we did a lot of more best practices around this, and we were able to scale the quality faster by doing multiple shift left. And then we were able to see the very minimal production defects that is going into the customers. So there is two of the one problem. So what is that? Like shift left and scaling right. So what does shift left is? It's basically catches the problem earlier by moving the quality upstream. So when I say the quality upstream, so initially we used to think about, okay, the developers the requirements comes in, grooming happens, and developer picks up and builds their development activity, and sometimes they write UTs and then ITs, and then it goes to the QEs. Okay. It's like, okay, quality, it's your responsibility to address it. No, it's not like that. We have moved quality one step. Okay, development, what can we address it? Okay, can I have something around my UT coverages? Can I have something around that IT coverages? Then a process has come into place, and then shift in the mindset has come into place. Okay, fair enough. We are able to see much more tractions in terms of the reduction in the defects. Okay, what can I do? Okay, I'll do one more shift left. Okay, to my design. From my development to design. Okay, we were able to get additional more transactions to the previous ones. Okay, fine. What should I do now? Next, I'll move to my requirements. So this is where like we, significantly moved from the quality to the code to the designs and to the requirements. So we were able to see how cheap the defects can be fixed at the early stages of the requirements itself. And then what is scale right? So keeping the quality is consistent for us. Like, we work on various different teams, but, without growing the QB headcount linearly, how did we scale it faster? So, which means like we added multiple pipelines to our existing process that includes of the, the requirements pipelines, UT pipelines, IT pipelines, and then the regression pipelines, with all of them are embedded with AI, which gave us more tractions, and we still operate with the same QB headcount by additionally adding to the developers, and we were able to support multiple teams. As I did mention, it's a mindset shift. It's not about changes on the faces, right? It's basically the changes on the mindset has to happen. Okay, during the requirements phases, what should I? So we have to break the requirements into the testable components and see is the scope or the requirements is having the proper acceptance criteria. Is my test case design as as every pieces of the line of code is written, or is every pieces of the data that has to be tested? It has to be thoroughly thought through, and the requirements has to be in a way that it should describe every pieces of the code or every pieces of the integration that covers with the proper acceptance criteria. And then my design review. What goes into my design review? So basically, we have a architecture design code. So the architecture is being reviewed across the board to see nothing is getting messed up. Okay, sometimes what happens, a Scrum team does a architecture probably on a high level or low level designs. Probably they are not consulting at the architecture reviews, a team where that has like principal engineers, staff engineers, architects. What happens, like they operate on silos, and there could be a opportunity where the defects can slim through it and it goes into the production. So these review boards catch up. Okay, I have a requirement built in. Probably haven't catch up my downstream. You are subscribing to my downstream services. Okay, there is a catch. So such reviews actually becomes an eye opener, and it bridges the gap that can be addressed proactively than on the reactive, disclosure of the defects. And then the solid principles. Before we start anything, following the solid principles is what we have mandated to the team. And then goes into the quality gates. So we have multiple quality gates. I've put them few. So what is the current static analysis of our code, and what is the total coverage, and what is the critical violation? So we have a lot of violations in terms of vulnerabilities and securities. So all of them has to be, caught in the quality gates itself. It just not only, look into your static code, it actually analyze your entire code base, and then it brings you more of coverages, brings what is the current coverage base. Is it meeting to my baseline number? Okay, if my baseline is 95, then the quality gates kicks in and it pushes you an alert, and then it doesn't, allow you to push your changes in, to the next, your repositories or branches. And then what is my security and vulnerability? Is there any critical violations? My password is getting exposed. So all of them are being enforced. It is not requested. So basically all of these quality gates are enforced in across the different stages. And then, we have seen like there is a lot of reduction in terms of exposing of securities, exposing of threats, exposing of vulnerabilities, and more importantly, sticking to the baseline coverage or the threshold that has been set. And then the continuous feedback. So basically, it's just not one-time practice. You have to keep evolving. How do we keep evolving? It has to be a continuous feedback. You have to, it could be a weekly or bi-weekly or a monthly. You have to, connect, you have to capture your quality matrices, and you need to, discuss with the team and maybe open up a forum where, where every team comes into and then they engage into a discussion and they speak more of their quality metrics and how can we say, for example, currently we are in yellow or we are in red. How do we transition from red to yellow to green, or we are in yellow for the last 2 releases or 2 sprints, and how do we get into yellow to green? So that, the path to green or path to yellow is being discussed during those continuous feedback discussions. And then the peer code review. So it's another place where, it becomes more of a process and things like that. It's being stick to it and bind it together. So it's every changes that goes into it before it merges. So we actually have a quality gate before things gets merged. So during the peer code review analysis, we actually check if every integrations have been addressed correctly, if every transactions are being tested thoroughly, the third party integrations or whatever this. So that goes with the code. The peer code actually, they basically review your UT coverages and your IT coverages. If there is any functional test that has been embedded as part of your quality gate, so everything has been thoroughly reviewed in the code. So we all know this, the testing pyramid and CI/CD process, right? So basically it starts with the unit, and then it goes with your integration, and then it goes with your end-to-end testing. And then basically in your end-to-end testing, you do your functional regression, and you run your end-to-end use cases and everything. So why this matters, right? So basically, in my experience, I've seen majority of the issues are caught within minutes and seconds in the unit test itself. Because if our unit tests are very, very, covers most of the requirements that has been built and the lines of code that they've been writing and the integrations that they do with before any component. So the UTs catches majority of the defects So we have seen like 70% of the defects is being caught using the unit tests, and the 20% of the defects are getting caught in the integrations through your integrations or APIs, components, and then to your in third-party integrations or any of your downstream interactions. So all of these, any basically a piece of code, works on its own. Another piece of code works on its own. So when they bind it together, when they goes in integration, we may not know what happens, right? The quality goes under the DOS. So we actually connected all of them, and we have strengthened our integration testings, all the components level of testing, API integrations, third party integrations, and we have seen like 20% of additional more defects have been caught during the integration phases. And then finally, the end-to-end testing is where we run our regression testing, we run our functional testings, where we run it in customer environments as well as we run it in our lawyer environments. And we have seen like 10% of the defects have been caught before going to the production. So, which is like before going to the pre-productions, we have seen over release, we have seen gradual reduction in the defects by doing the shift left practices. That has given us a more confidence in going to the releases, and that has also gained the customer confidence as well. So what is this gatekeeper pattern? In the quality gates, like we brought in something called as the gatekeeper pattern. So the gatekeeper pattern is something like, it actually has certain rule sets, and what it does, it actually it stops you in shipping your bad code, and it results in faster feedback with the consistency standards and no human bottleneck. So we have around like 16, 17 gatekeeper patterns right now available. It varies from different repositories to repositories, and every gatekeeper pattern has its own set of quality gates. It actually covers certain checkpoints. Basically, it's a non-negotiable one. Okay, non-negotiable checkpoints that decides whether the course. Say, for example, think about you have a repository and multiple team members is contributing to it, and there are third-party team or there are cross-functional team internally and externally. They contribute to your repositories. End of the day, what happens here? When you don't really own it, when you don't really have certain checkpoints, so you may not know what happens. You have your pipeline that is running. Potentially one PR can break everything. Maybe someone might have missed to validate their compilation, right? And then it can potentially break your thousands and thousands and thousands of your tests. So we have addressed all of them in a gatekeeper pattern. Our gatekeeper patterns has in a different, so we have, as I said, we have 17 different gatekeeper patterns, and every gatekeeper pattern has its own different, quality gates. It has its own objective, and it has, more importantly, the non-negotiable checkpoints. So for example, one of the gatekeeper objective that I can describe is like, we have embedded the smoke test, and the smoke test cannot run beyond 30 minutes. Irrespective of you scale your feature, you add more of your components and things like that, like it sticks to 30 minutes, and we have to filter our smoke test that could run within 30 seconds, 30 minutes. If it is not happening, then it sends you an alert basically. So we actually analyzed our own problem, and we came up with a different kind of a quality gates to make our risk from red to yellow and yellow to green. So what is beyond basic? Okay. What should we do? We should actually level up our pipelines. So when I say level up our pipelines, we have to be faster and we have to be efficient. Okay, what it takes to be faster, what it takes to be efficient. So to take it to faster, we know that we run the sequential test, right? Like probably it might help you out, but if you think about an enterprise level organization, it might not help. We have more than 10,000, 12,000 of tests, and we have about 39,000 of ITs, and we have around 70,000 of UTs, and then we have end-to-end itself, we have about 12,000. Think about in a place where a bigger enterprise organizations operate, where it is very difficult to run the tests sequentially, to run through the pipeline. So what we have built is like we have built a concurrent process than the sequential. We have built multiple parallel threads, which invokes the executions, and the executions becomes faster. And we have reduced the time to, by 83% reduction in compared to the baseline numbers. And then intelligent based selection. So you have your pool of tests. It's like, 12,000 or X number of tests, right? But I cannot run all of my tests to a specific release, tagged to a release version or a minor release version or maybe a customer version. How do I pick them? I have to choose my test intelligently rather than, putting every backlog of my test into the pipeline exit. So, okay, if a customer is picking up a specific version or a specific application of the products, specific ecosystem of the products from your entire application. So what they do is like, okay, you have a suite of product. From the suite of product, I'm taking ABC products as my ecosystem. I wanted to, I wanted to only understand the quality of these products on X versions. So I cannot run the every test in my suite. I have to choose it in an intelligent way. And we have done it through ML-driven prioritization. We have multiple internal applications whenever the customer is choosing from our base test suite through ML, we have identified the tests that the customer is going to pick up, the application the customer is going to pick up, and also some of the customer related use cases. And we have made it more intelligent test selection than the human driven one. And then, and then the next thing is the self-healing techniques. The self-healing techniques is one of the most important things that I'm seeing in the past 2 years, because in any organization, when you are as dynamic and then as you are growing up, your test becomes flaky. Because I can give you an example. So in our current organization, we are working on an application, web application, and suddenly a couple of customers have came in to address more of their accessibility changes. But think about the accessibility changes are getting inside your core components, your React components or something like that, right? And everything goes into, your front end changes, and something breaks your front end, or think about your back end changes. Things can potentially break and your test can become flaky. So this is where we have introduced self-healing techniques, where the automation scripts, the agents which we have built, it actually analyze the test, it finds the flakiness, and it diagnoses the flakiness with, retry the options. And then the production testing. So this is another important a piece of thing that we have seen when we go to the production. So we have seen a lot of issues from our lower environments to the customer lower environments. So certain things happens in the customer environments may not happen in our environments. So what we have done is we have come up with the different strategies of addressing them through canary deployments, through feature flag testings, and then through A/B testing as well. And then the shift right practices. So there have been a lot of chaos when, as the engineering was, driving faster, we were not able to, significantly add more QBs, but eventually we were able to bring more of quality automations in places like the UTs and ITs and the functional testing, which were able to help us drive seamlessly and validate the quality before and after the releases. Shift left alone doesn't scale. Okay. So I have shift lefted. Okay. My dev is doing my dev is writing UTs, my dev is writing ITs, and my product team is capturing each and every acceptance criteria. Is it solving my problem? Eventually, it solves the problem to a level, but not 100%. So every gate that you have, every review that you do, and every quality practices that you continue in each and every process, stages of the process, right? Like, you should maintain it and you should review it. The consistency of getting above the line is you have to keep them continuously reviewing and continuous feedback, and then having a path to green that makes the team much more efficient and deliver faster with respect to the shift left strategy. So automation AI are the bigger force multipliers as of today, in the current AI world where we are living. So both automation and AI are the force multipliers we need to stick to. So as a fixed any quality engineering organization, so they cannot manually extend the shift left practices, right? So okay, I have shift left it. Can I yield efficiency? Can I yield faster? So that's not going to happen. So basically, you need to think through these multipliers, which is the automation AI. So you need to bring more of your AI augmented test, which is like, AI generation test through your LLM practices of building agents that can, understand your instructions, build skill sets, build spook, and it can, run through the test through the agent. So which means your AI can generate the test. And then the next step, okay, now the AI has, able to efficiently, generate your test and artifacts for about like 80% or 90% of efficiency. Then you have to do X, like probably 5% or 10% of review and connecting those dots. And then what happens next? Okay, now I run my test in the pipeline and the flakiness comes into the picture. That's where the self-healing automation comes into the picture, where you have to have your self-healing agents that can understand the flakiness, that can study the history of the flakiness of any test cases, and then it does the diagnosis of the test cases. So basically, if there are changes on the UI, if there are changes on the backend objects or UI locators, actually your self-healing agent should be able to understand them. How do you make your self-healing agent to understand? You have to train your agent. You have to instruct your agent in a way it actually captures those and it does those diagnoses. And then the final thing is like, the tooling and the plugins to your existing systems, which is like, your MCP integrations connecting to your Claude or Claude or your Jenkins, test files, Sapphire, Jira, and any of these, and then get it. So flaky tests. So this actually become, our enemy on the pipeline. It's just not only on the end-to-end test or functional test. That was on the unit test as well, on the integration test as well. So we had a zero tolerance policy across the functional test, unit test, and integration test. It is a zero tolerance policy. So we have come up with a mandate of fixing any of this flaky test within 48 hours to disable the actual failures, right? So basically we want to do, so the suit runs and it gives you certain failures. So we actually do not know like whether it is an actual failure or is it a flakiness. So we actually wanted to, bring out the actual bug out of the flakiness. And that's where this policy has helped us to fix this flaky test within 48 hours. And then we had a dedicated test officer, which is like, every team had a officer. You think about an on-call rotation, or maybe you think about an on-call warrior, where every team has one of the on-call warrior from their team. We do 24/7, and then it goes on to an roster, and then we have a dedicated on-call engineer who looks into the flakiness and he or she basically address, and the rotation continues across the team. And by the way, we flag them, the root cause, and then we fix them, and then we run them. So this actually saved a lot of our critical defects that are going into the production. And then this also became a platform where we actually collaborate with the teams, cross-functional teams, and then with an external teams to understand the interdependencies and fix them. And then our environment became stable. And then it gave us more of confidence and gave us most of our releases goes with the Go confidence, and this is where we will achieve. So making progress is what it makes us, going, as I was telling, right? Like currently we are in red. How can I go to yellow? From yellow, how can I go to green? So every team comes up with, a path to yellow, path to green kind of a strategy where we have an adoption scorecard. Okay. What is this adoption scorecard? Basically, we have certain matrices in which we calculate the adoption. So there are certain readiness question, and then we are capturing manual efforts per sprint, and then the flaky test rate. So we have 5 questions. Okay, are these tests okay? I've built UT, I've built IT as part of my shift left. Are they running in my CI? Okay, any tests which are not running in CI, it doesn't make sense and it doesn't add up any value. So that's where we have a questions. Okay, I've built UTs or I've built ITs. Are these tests running on CI on every commit? Not just nightly. It has to run on every commits. And then there are tests that we run them right nightly. And then its coverage is over and above 70%, 90%, 95% gate with 0 critical violations. Is your test flakiness is under 2%? Is there any exceptions or test maintenance that has been done before? Are the quality metrics visible somewhere else the team can check the unprompted way? So we actually and more importantly, there is one more thing is your acceptance criteria validates each and every data sources. So we actually have a multiple readiness questions, and every Scrum team has to address those numbers. Okay, am I addressing 5 out of 5 or 4 out of 5, 3 out of 5? And then is my manual QA hours per sprint? What is my manual QA? So basically, we capture the manual QA hours per sprint. Is it like less than 20 hours per sprint? Is it like less than or equal to 50 hours or greater than 50 hours? Is my test rate, flaky rate is less than 2%, 2 to 5% and greater than 5. So basically if any of these teams falls in this category, so they go into green, and any of the teams which falls into the second one, they go into yellow, and any of the team that goes into the third one, they are following 1 to 2 readiness questions, and then they invest more than 50 hours manual, and their test suits are flaky more than it's red. So when the team gets into categorization of green, yellow, red, they actually have to come up with a strategy of moving from red to yellow. Okay, now I've used my manual hours is like more than 50 hours. Okay, what are my steps, or what is my strategy that I can take in, and I can put it in my practices, the Scrum process, where that can reduce my manual efforts less than 50. Okay, currently it is 50, and what is your goal, and what is your strategy going to get you there less than 20%? So that's how we transition from red to yellow to green. And there are teams, they've been consistently with green. There are teams that are consistently with red, but we cannot always, go right immediately from red to green. It actually takes time. We need to understand the level of automation we have, the level of coverages we have, the level of flakiness we have, and the amount of the quality gates that you have, like it could be 70, 80. How are we going to get in there? It's that consistent practices throughout your Scrum and sprint deliverers get you there to yellow or green. So, and then the tool shift it's made a difference. So automation is not everyone's job. So it's not just only SQV alone, and it actually it was everyone's responsibility. So automation, it could be writing of UT, it could be writing of IT, just not only writing the automation test. So testing actually is a tool. It's not a burden. So initially, a lot of organization actually thinks about, okay, testing is actually it's a tool, but actually it's not a tool. Actually, you shouldn't think as a burden. Actually, we have to basically whenever we think of testing, it should be act. It should not be forced to make something work. Everyone should think through why do we need it, and what is the level of quality we are today, and what it will take us to the better quality, and how can we deliver it to the customers. And then the changes on the leadership level and the organization has to think through how can we mitigate the quality, how can we bridge those gaps in terms of quality depths and the backlogs we have. And then celebrate your coverage publicly. So we had coverages of around 10%, 3 quarters before. We are at 50%. It looks like 40% of transition, but again, within 3 quarters, think about you are able to get from 10% to 50%. It's a huge one. So that those shift in the practices and cultures makes the difference. So one of the case study which I wanted to speak about is like, as I was telling, we had about over 12,000 of UI regression tests. And when the regressions were scaling faster, and when the regression was running in one pipeline, so we wanted to dedupe all the retry and then the failures or dedupe across the retries before the triad. So the engineers actually gets the real signal or the rewrites. And then the failure categorizations. After every run happens, we dump the failure categorizations in our dashboard. Basically, we are using Grafana, and all of these categorizations are added to your Grafana dashboard. Okay, it gives you a classification of the defects with the heat map. Okay, how many tests are flaky, and how many tests are flaking because of the locators, or how many are the real bugs, how many are because of the environment, and then the heat map. Okay, this specific test has been failing for the last 10 runs, and that needs an address. So we have built our own dashboard, which gives us a real-time insights, and it has been built using AI and gives us a very wider visibility across each and every test suits, across each and every test like UTs, ITs, and functional tests. And then Cloud Code. So we actually used a lot of agentic methods inside our code generations, where basically the categorization happens. Once the categorization is done, and if it is determined, if basically if my agent able to understand if this is because of the flaky test that has changed in the OK test, so actually it diagnoses it, and then it reduces the triaging timeline so that it is getting ignored from the real defects actually. And then another case study. So wiring AI directly into the quality toolchain. So connecting through your MCP service, connecting through your agents, connecting to your any of your AI, right, which your systems can readily live in. You can connect through your Jenkins, to your test case management, your version controls, and then your maybe your Jira or your Azure or anything. So every every path to success we need to determine that. So every path in sense like Jenkins is one place where we run thousands and thousands of tests, and then we have a test management tool, and then we actually have a test management tool where an agent, it actually converts your test, which is from your requirements from your Jira to your readable, and then your GitHub, where a lot of PRs have been reviewed through your Copilot. There's been a lot of AI has been added to read through your codes and make it more efficient in terms of your code quality, and then the Jira. So why this is needed? When I say shift left, as we are growing faster, as we have never compromised in getting more qubits, what we did was we were able to build a lot more of MCP servers, a lot more of agents in place to make things faster so that it becomes easy for the developers. It becomes like a dev productivity, and then, developer friendly. And then it was more importantly, it was focusing on quality. Okay, lessons and pitfalls that we learned during the journey was shift left without ownership. It's a bottleneck. Actually, we need to have a dedicated ownership, and it has to go through the feedback loop, and then the owner should be more of sticking to a point of not negotiating in the shift left status. And then scaling automation without shift left. It actually makes no sense. And actually, it's the same mistakes that we keep repeating. We actually have to, when we think about shift left, in parallel, we need to think about scaling automation as well. And then tooling integrations issues. Think about you need to scale automation, but how do we bring more efficiency into the tooling, or how can I bring more the faster tooling integrations, like your test management tool, your version controlling tool, or your automation tools, open source or anything. And then finally the dashboard. No one actually checks the dashboard, right? So it actually, a dashboard is a dashboard which is actually getting created. So it's not like that. Actually, we have a dashboard, and right from the TLT and to the next level of leadership, the dashboard is being reviewed bi-weekly for each and every team. And we actually, with the adoption score, where the teams are standing and where is the path. Where are we standing today? Is it green, red, yellow? What is your path to green? What's your path to yellow? It's been mandated. So looking forward, where is this AI-driven QE goes next, right? So our current reality, we actually generate a test using AI for production use, and then we use the self-healing techniques and the locators for the flaky test, and then moving your tickets from your requirements to probably your readable test case conversions, or test script generations using agents. So we are in a world, we pretty much do this. So what I look forward in the next 2 to 3 years, you have your agent that fully autonomous in terms of test maintenance. You have a AI agent which can do everything whatever that we do today from end to end. And then you have your AI driven quality prediction before shipping code. Okay, the the quality predictions will come into picture, stating today we human take a decision of saying go, no go to each and every releases. So what I see in next to 2 years is so that human driven go, no go decision is going to be slowly going to get fade out. And then, AI driven quality predictions are going to come in to say, are we good to go to the production or are we not? And then more of a natural language test creations are going to come in picture, and org-wide quality dashboard are going to be published on its own, rather than the engineers are driving those things. So wrapping up with the key takeaways, shift left, scale right, and deliver excellence. Shift left is a mindset, not a phase, and quality should move upstream, all the way from your quality, your testing, to your code, to design, from your design to requirements. And then shift left alone doesn't scale. You have to scale it to your automation AI and keep it affordable within your number of teams. And and then the culture beats the tooling every time. And you have to bring more of your culture mindset when you are trying the shift left. And then start with visibility. It doesn't matter. Today we might be 0 or 10. Where are we going to be there in next 1 quarter, next 2 quarter, or end of this year? I'm going to be from 10 to 50 or 10 to 40. So start with the visibility, exchange your scorecards, exchange your, your pitfalls and your common problems, and set up a target and move towards it. Any questions?
Thank you, Vishnu. Thank you, Vishnu, for the wonderful session. So it was actually really packed with so many practical insights. So we actually started with the problem statement that quality does not break at code level, but it breaks at org level. And so with that, we understood now that from testing pyramids and quality gates to the AI assistant pipelines, and also the shared ownership, that there was a very tremendous value for each and everything, and also the mindset plays a very key role in each and every step of this. So, but one message has actually stood out for me clearly, that quality is everyone's responsibility. Like it's not like responsibility only for one or anyone, but it is responsibility with everyone. So thank you for that, Vishnu. It was really a good talk. So now let's take up a few questions. Then yeah, so we have a few questions in the Q&A section. We see that you mentioned that quality breaks at the org level rather than the code level. So what are the earliest signs that an organization is heading in that direction?
Can you come again, Harshil?
Yeah. So you mentioned that quality breaks at organization level rather than the code level. So what are the earliest signs that an organization is heading in that direction?
So the signs, I wouldn't say as signs. It's more of, where you have to get an understanding, right? So the signs will be everywhere, or each and every time of your releases or your production push happens, right? So at times, okay, for example, I've seen in most of my cases where whenever we are releasing any bigger releases or a minor version releases, right? So we actually look back and see the coverages that we have had. There are teams where they make more quality responsible and they write the test UTs and ITs, and there are teams which doesn't. So we have taken up a call and we have said we are not going to release it. We need a coverage. So it's more of a you have to understand your current dynamics of your quality and how it is getting progressed, and then you need to make up the decisions, and then you need to stand by it, and then you need to do it consistently, and then it actually, that's what I say, like when during your development, when you have to get things faster, there are teams which compromise on quality, which they don't write UTs, they don't write ITs, right? But as a quality engineering you have to stay on top of it, and you need to keep pushing that, and you need to set that as an expectation. And if not, go for the no-go release. Most of the times we have went for the no-go releases, and which means like, it's because of the quality, where we have seen there is no proper UTs or proper ITs covered as part of those feature releases.
Okay. Yeah, thank you, Vishnu. Thanks for the reply. So we'll move on to the next question. So the next question is, which measures you take to keep your smoke tests under 30 minutes despite the scaling number of features to take in the smoke test?
Oh, that's a fantastic question, actually, right? So as we gradually grow, and as the product ecosystems become, uh, way better than what we were there a year before, right? So this is where you need to be very much kind of you should have an eagle eye on top of everything. I cannot have every of my test under a smoke test. I need to keep my critical workflows. So what are my critical workflows? That has to go through your cohorts. So I'm not sure how many are making decisions or building tests by using the cohorts and the defect stratifications. So I basically use two major things here. I use the defect stratification data from the production and as well as the non-production defects. So from my defect stratification, I actually keep my smoke test, which goes real sync with my defect stratification data. Okay. My defect stratification data says like X% of the defects comes from, which is like 50% of the defects comes from feature A or module A, B, or 20% of the feature defects comes from B and C, right? So that is one input that goes into my equation. Another input is my cohort. Basically, your user-driven equations and your user-driven events. So from which you'll be able to understand how the user journey is getting built so that you build your smoke test. It stays on 30 minutes basically, right? It's not that 30 minutes, you cannot exceed the 30 minutes. It's basically, I want you to keep it within 30 minutes so that it makes the decision faster to say whether this build can be merged to your master or maybe to your any of the features. So basically, this smoke test is not running across all the merges. So it actually runs on top of the master merge and as well as it runs on top of the feature merges. So any of the features that is going to the customers, we actually look into those data pointers that are driven through events and then the defect stratification. Okay.
Yeah. Thank you, Vishnu. So by the time we move on to the next question, so I request everyone to please provide valuable feedback which we delivered right now. And have the link as well. So moving on to the next question. So how high are your token costs using AI heavily to automate and field test cases across teams?
Okay, so that's a good question actually. When we heavily focus on AI or when we heavily give importance to AI, the token becomes a bigger bottleneck for us. So what we do is like we actually have a marketplace, internal marketplace in our organization where multiple enterprise level teams are contributing to the AI marketplace. So one of the best practices that I have emphasized and we've been following is actually we write an agent or we build an agent and we train it with the instructions and skills and hooks. What goes next? Actually, we run through a couple of POCs and we run through whether what is the efficiency rate it gives to us. What happens next after we solve it through an AI problem? We actually have a review discussion with the ML and AI team. We have an internal AI team and where we have the AI engineers and ML engineers. So as a token of efficiency improvisations, we get to them. Hey guys, like, this is where we are currently standing and potentially, we are able to optimize the tokens of usage, say 12K tokens, we have reduced it to 9.5K tokens. And then we review with them and we see an opportunity there to reduce the tokens and we have improvised. For example, for one of the agent, it was using 16K tokens. We were able to reduce it to 14.5. And then with the use of AI teams review and then the help of AI and ML teams, we were able to get it to 7.5K tokens. So as I told, right, it's something we cannot make more impact. I think the collaborative efforts, we're getting into the AI and ML team, getting things, whatever you build, getting them review, and then pushing to your AI marketplace makes more, makes more easy wins, brings more easy wins than what we do as in silos.
Okay. Yeah. So maybe we'll move on to the next question then. So we have a question about some actually it's a bit personal is what I would say. So what would be the maximum salary which an AI tester can have in India. So do you have any insights on that, Vishnu?
I would say I can pass this question because it actually depends from organization to organization and size of the organization.
Okay.
So I've seen companies where they solve core AI problems where they are giving good salaries. I think things are available in uh, Glassdoor and other places, but I think I really don't want to take up on this. But yeah, but I would say
Okay.
there is a lot of growing opportunities in the AI field for a tester, and yeah, it's a good place to explore and get ourselves familiar.